Welcome to the Explainer. I am so thrilled you're joining us today. So, think for a second about how a traditional operating system is put together. Usually it's kind of like a house that's been renovated 50 different times over the decades. You've got files scattered everywhere, configurations completely mixed up, and those updates that just unexpectedly break everything. But what if we completely rethought all of that? What if an OS behaved exactly like highly engineered, totally predictable modern infrastructure? Well, today, let's unpack AerynOS together. This is a project that's executing a foundational shift in how a Linux distro actually operates. We're going to look at the very building blocks of this system to see exactly why it's turning so many heads in the tech world.
Okay, let's dive right into our roadmap for today. We'll start by meeting the new AerynOS, and then explore this concept of the OS as infrastructure. After that, we'll get an understanding of atomic updates, check out their custom Rust tooling, take a peek inside the Stone format, and finally, wrap up with the future of Linux.
All right, moving right along. Section 1, meet the new AerynOS. Now, if you follow Linux development pretty closely, you might be scratching your head wondering where AerynOS suddenly sprang from. Well, as this April 2026 report from Linayasak points out, the project was actually formerly known as Serpent OS. Yeah, they recently went through a quiet but super comprehensive branding rollout. They adopted the AerynOS name and rolled out this completely new triquetra-based logo with a really fresh green and orange color palette. So if you are already tracking Serpent OS and its highly anticipated atomic architecture, this is literally that exact same project, just wearing a sharp new suit. And let me tell you, they are absolutely not sitting still. Their April 2026 update dropped a massive, totally bleeding-edge package stack refresh. I mean, we're talking GNOME 50.1, KDE Plasma 6.6.4, System 76's Cosmic Desktop at version 1.0.11, and the brand spanking new Linux kernels 7.0. They're pushing these highly current modern desktop environments specifically to stress test their underlying architecture. They want to prove, for sure, that they can handle the heavy lifting of today's most demanding software. When I first dug into this, one specific choice for their alpha ISOs really jumped out at me. In their custom in-house installer, which is written entirely in Rust and brilliantly named Lichen, by the way, they shifted to making KDE Plasma the recommended default desktop environment. It's a very deliberate nod to the maturity and raw performance of the Plasma 6 series. And that's exactly what users are going to see right out of the box. Okay, let's shift gears a bit. Section 2, the OS as infrastructure. So, in a traditional Linux distribution, the system is stateful, right? Package files and your own personal configuration files are often just completely mashed together. When you update a package, the system modifies files right where they sit. And honestly, that can be incredibly frustrating when things just randomly break. Well, AerynOS essentially throws that whole concept out the window. They believe doing things the old way just leads to system rot. Instead, they operate on strict isolation. The system is the system, and your data is your data. It is an incredibly refreshing approach. And that brings us to a foundational rule of AerynOS, statelessness. This is often referred to as a hermetic/USR. So what does that mean? Basically, packages in AerynOS are strictly forbidden from placing any files whatsoever outside of the USR directory. Your personal configurations, those live safely inside etc and var, which belong exclusively to you, the user. By designing the system this way, they enforce same defaults right out of the box and completely eliminate those dreaded three-way merge conflicts during package updates. You are literally never again going to have an update overwrite a conflict file and brick your system. And this philosophy of ultra-clean infrastructure goes all the way down to how the system actually boots. Get this, AerynOS has completely eliminated standard legacy bootloaders like grub. No way, right? There is no /etc/default/grub file to mess around with anymore. Instead, the OS dynamically produces the root parameters for the kernel command line natively in Rust. It just reads the superblocks of your devices and generates pristine bootloader specification entries. If you were to accidentally wipe your EFI system partition, the AerynOS tools can literally just rebuild the whole thing from scratch. It's wild. Let's dive a bit deeper. Section 3. Understanding atomic updates. Now, you hear the word atomic thrown around a lot in modern tech, but what does it actually mean for a Linux distro? Well, in AerynOS, an atomic transaction means that a completely new, entirely self-contained root file system is built entirely in the background. Then, once it's fully verified and ready to go, the system uses a native Linux command to swap that new tree into place instantly. This means an update does one of two things. It either entirely succeeds or it fails completely safely without touching your active system at all. There's no more of that half-updated, totally broken state because your laptop battery died right in the middle of an upgrade. And if we look at their data logs from February 2026, the blitting speeds, which is basically how fast it generates hard links for that new atomic file system, are just off the charts. On modern Gen 4 NVMe drives, it's hitting around 765,000 operations per second. To put that into perspective, a fresh AerynOS install has roughly 65,000 files. That means on modern NVMe drives, parsing an entire operating system takes, about 1 single second. That's it.
All right, so how do they actually pull this off? Section 4, the custom Rust tooling.
To achieve those blistering speeds and instant atomic swaps, you obviously can't rely on 20-year-old package managers. You need something totally purpose-built. So AerynOS relies on a bespoke trinity of tools, all written completely from scratch in Rust. First up is MOS, which acts as the system state and package manager on your actual machine. Next is Boulder, which is the tool developers use to actually build the packages into the correct format. And finally, there's Summit, their infrastructure build controller and web dashboard that actively manages the queues of packages being compiled over on their servers.
But it's not just about creating the files. An update also requires triggers, things like building plugin registries. Because of intensive Rust optimizations and parallelizing tasks, the execution time for these triggers has been completely slashed. Stuff that might take minutes on an older hard drive takes literally 2 seconds on a Gen 4 NVMe. It makes the entire update process feel subjectively instantaneous to the user.
Let's crack open the packages themselves. Section 5, inside the stone format.
So, if they aren't using deb or RPM files, what on earth are they actually installing? Well, they use a proprietary format called .stone. Unraveling how this works is honestly like looking at a brilliantly designed puzzle. Inside a single stone file, there are 4 distinct payloads. There's the content payload, which is heavily deduplicated so you aren't downloading the exact same libraries twice. There's an index payload to map out that data, a layout payload that tells the OS exactly how the file system should look, and finally, a metadata payload for package names and providers. And because the header is totally version agnostic, they can evolve this format infinitely without breaking legacy systems.
So how does a stone file actually get used? Well, spoiler alert, it doesn't get installed in the traditional sense at all. First, the system fetches the stone. It decompresses the content in a single pass. Then it splices that data directly into content addressable storage, which is essentially a deduplicated cache. Finally, it loads the layout into a database. The system is just staging the pieces, getting them ready to be atomically swapped during that next transaction we talked about earlier. It is just so incredibly clean.
So where is this all heading? Section 6, the future of Linux.
What's the ultimate endgame for AerynOS, and what does it actually signal for the broader Linux ecosystem? Well, AerynOS is moving toward what they call immutability without compromise. While a lot of modern atomic OSs kind of force you to reboot constantly to apply new layers, AerynOS plans to implement ComposeFS-like EROF's metadata, utilizing overlay file systems. This is going to give users the absolute security and reliability of an immutable system while retaining the sheer convenience of applying live updates without forcing a system restart. Honestly, it's the best of both worlds.
And looking ahead, their upcoming push into Phase 2 focuses heavily on versioned repositories. In this phase, the main repository index will tightly link software releases to specific tool versions. This is absolutely crucial because it ensures that as the AerynOS package format evolves over the years, the system can perform incredibly smooth, completely unbreakable self-upgrades. It basically guarantees that a user is never left stranded on broken or outdated tooling. You are not going to end up with a bricked system 5 years down the line. Which leaves us with this final thought. AerynOS has clearly shown that by burning down those old stateful paradigms and treating the OS as strict atomic infrastructure, you gain insane speed, reliability, and just general sanity. As you look at the persistent breakages in traditional software today, you really have to ask yourself, is this atomic, stateless model not just some cool experiment, but the inevitable, necessary future for every single desktop operating system? Thanks for exploring this with me today. Keep asking those big questions, and I'll catch you in the next explainer.